Hello and welcome to this video in which I will be explaining you how to use kernel map hazard-free. This is done by Alfredo Valdez. What if we have a true table and we want to add another variable? The true table is going to be huge, so you might trying to do this with a simplification method. This is not something I want to do. So what we're going to do is we're going to convert a true table to a K-map table. This is how a table looks like. We got our variables A and B, and C. So we're counting here, and we're doing it with gray code. The code is 0, and it changes one bit, 1, then we change another bit, 1, and then we change another bit, 1, to 0. Okay, so here 0, 0, change 1, so 0, 1, change another one, just one bit, 1, and then finally the same thing, 1. Okay, and here we put a 0 and a 1. Okay, now we do the same. We look at one row that has an output of true, and we bring it over here because we got 0, 0 for A and B, 0, 0, and 0 for C. So that's the first one. So that's true. So we're going to put a true here. Okay. Now we look at the second true value. So we look at here and it says 0, 0, 0, 0 for A and B, and 1 for C. So 1 for C. So right here. And it's a true. Then finally for another one, this is 0, 1, 0. And this is false. So we got 0, 1, 0. So it's right here. And this is false. And you keep doing this for all of them. Just look at the numbers here. A, B, 0, 1, 1, and so on. And you're going to be able to fill all the table like this. Okay? Now, this is a little bit easier for you to understand. In our book, we use the letter M to represent the spot. But I'm going to use the R because I think it makes more sense to say it's a row. So, for example, this row, it's going to always be placed here, row 0. This is always going to be the place for row 0. Okay? Now, for row 1, it's going to be placed here, and so on. So this is the complete mapping for the K-map. Okay, row 0, 1. So this is the spots that represent here. Okay? Now, if we have a big table like this, it's going to be represented like this in the K-map table. You can see a big difference between this table and this table. It's much easier to read it in here. Now, if you want to get our function in order to get this output, and this is the mapping for that one, so let's get rid of it. It's not going to help. But we look at this too. We always pair in groups of 2, 4, 8, and so on. Okay, so we look at this too. We say, okay, that gives us f is equal to a naught. And how do I know this? I know very simple. A, B. So I look at these and I say A, which is my first number, is this one, is an A naught. B, which is my second number, is a naught. So I look at this line and I say, well, A doesn't change, B doesn't change. So A naught, B naught. Now I look at C and D. This is C and this is D. This is C and this is D, and so on. So I look at here and I say, okay, C doesn't change, but D changes between this one and that one. So the only variable I'm gonna care is C, and C is not. So A naught, B naught, C naught. D we're not taking account of this one because it's changing. So it's changing the variable. So we can't look at them. Okay, another example. So we're gonna look at this. Okay, here we have another group of 4. So we do the same thing again. We look at A and B, we say, okay, A is changing 0 to 1, but B is not changing, B and B, so it stays. So we know that B and not B not, but B, because it's true, is going to be necessary. Now we look at the other side, and we say C and D. So C is not changing again, okay, so C is true. So we're having a B, which is true, and a C, which is true. But D is not, because D is changing, okay? So, because this line, and this line, this line, and this line. So we're taking account of this and this, okay? So we get a DC. And all of them, every time that you do a new grouping, you're gonna put an OR, okay? Now, finally, we're gonna do this grouping. So we did this one, we did this one, and now we're doing this one, okay, to finalize the K-map table. So now we look again. A is not changing, so it's A not. B is changing, so we don't pay attention to that one. But in this case, C and D are not changing because it's just one line. So we got C not, D. Okay, so we get A not, C not, and D not. So this is how we obtain the function. So much easier than just looking at this humongous whole table and trying to get each of them and trying to simplify the function and get to a result. Now, with the truth table of the K-map, it's much easier because we do it in grouping. Okay, but something we have to realize, and this is something really important, is that we need to look for hazard-free. Okay, is this hazard-free? Meaning that there is, for some variables, when you don't consider them, they can glitch. So meaning at some point, let's say that we're building a car airbag system. Okay, if we don't think in that, we can have a glitch, and small glitches can affect the whole system and not respond at the time that we need to. Okay, so yes, we do have a problem here, so we need to look at this line. Right here, we're having a glitch because we're not looking at this too. Okay, so in order to be hazard-free, we need to take in consideration this line. Okay, so we're gonna add A naught, B, D, which makes it safer, which adds some more gates to our design, but it will make the design respond in every single situation and not have a glitch and not be responding in certain times when the clock is ticking and we're not paying attention to this glitch. With this, I conclude my presentation. I hope this was helpful to you and you could learn the K-map tables and check for hazard-free. Thank you for watching and see you in the next one.